last for today, two more developers. One is a software engineer and a blockchain enthusiast, and the other one takes care of the UI and the UX. And they will talk to you about the journey of building an application on aeternity. And I presume they will be talking about the Graffiti App. Okay, give them a round of applause. Keno Dreßel and Philipp Piwo. Yeah, is that correct?
Thank you. Yeah, I think one is enough. Okay, let's start. The first app on aeternity. We got the initial briefing of building the Graffiti app, and we started with this in November 2018. And the idea was to enable decentralized graffiti on the aeternity blockchain. And then the idea would be that while people posted on the blockchain, we would actually transfer it into real life using drones. And this would be done fully autonomously. And so the idea of blockchain with like no censorship would be preserved. And the idea was to paint it on a huge wall in Mexico City. And in order to enable this, we would actually implement an auction mechanism into a smart contract that would limit the amount of graffiti on the wall and actually would allow the drones to paint it in a reasonable amount of time. But as it turned out, drones are a lot harder than blockchain. So we got the app working and we got the smart contracts working, but the drones weren't up to the task. So we scaled it down a little bit and went for the digital version. So now you can make digital art on the blockchain, and you can open our app and we will still do some transformations to your images, and it will be live rendered on a canvas. You maybe have tried it out already here on the conference. If you haven't, you definitely should. And there is a beamer that puts it on the wall. The briefing we had as well was we want to have it fully decentralized. So first, everybody should be able to run it. And secondly, it shouldn't require any centralized server. So what we do is we save all the artworks, the files, on IPFS, and then we store the IPFS hash of these files on the blockchain. And obviously the implementation and the server and everything is fully open source. But as we were the first ones who actually were building an app on the blockchain, or on the aeternity blockchain, we had some struggles. Of course, there was a limited set of tooling available, so we're talking about basically we started before Aeternity was even launched. And then the rendering on the artworks took some time to actually get up to speed. So we had to find some mechanisms to reduce the authority that the server had. And again, like the decentralized file storage, we had lots of timeouts, limited access. We had to run our own IPFS node, and more fun. And then additionally, this is where the server actually comes in, is that mobile phones are simply too slow to render all the images on your local phone. So we had to have a pre-rendered version on the server that you can actually view, so your phone doesn't die when you open the app.
So I will talk a little bit about the app development experience we had in general, starting from the issues we had at the beginning and how we did combat with these issues, and also where the tooling around us and Aeternity blockchain in general improved to help every app developer. So first, we had a limited tool set, as Keno already mentioned. There was no testing tool for smart contracts as we have with a project now available for contract testing. So we were posting our contract to like this really basic contract editor that we had online and test manually if it worked or not. And then only later, I think right before we had the first prototype ready, we were able to automate our contract testing. Also, tooling to highlight Sophia contracts was not available that we have now in IDEs such as VS Code, the Monaco editor in general, and JetBrains editors. Also, I think Nikita did fight really hard to get ACI or ABI functionality available so that the compiler can give us some information on the contract's metadata. For example, this is the functions available to you, this one is stateful, this one is not, and these are the input parameters that you have. So we can make a nice interface for it in JavaScript or any other SDK to make easy integration to allow for automatic encoding and decoding of all the data that we have. And also another thing that we didn't have in tooling was the base app. The early base app didn't allow to run contracts inside, also didn't allow to show an app inside, and we had to communicate or coordinate a lot with the base app team in the beginning to get it running. In the beginning, we also had certain issues with writing the smart contract as it is. We discovered a small bug in the EVM implementation. I think it was even the compiler, not the VM itself, where we had very limited data accessibility in mappings. So we were only allowed to put like 10 entries into a map, and then we got some errors that we couldn't, or that we could reproduce, but not figure out if it's our fault or the compiler's fault, and this was fixed eventually. And also in the beginning, there were a limited set of data types available to us. For example, addresses had to be hex encoded when talking to the HTTP API, and this was not very comfortable because we always had to have a lot of utility functions in order to be able to work with a smart contract at all, which is today it's very much better. And also there was no like standard library, and now we evolved some libraries that you can reuse over and over in different projects to make the developer's life easier to, for example, work with lists to iterate over them easily. And in the beginning, error messages were really bad. We mostly got like out of gas and unknown error, and that makes it hard to work with the tooling. Also, it was not only smart contract issues, but also any other tool was very limited in error handling back then, which is a lot better now. And we had some issues with general infrastructure. We had some bugs in SDK and base app. We had our problems with setting our own project up with a building pipeline to include all the dependencies we had with the crypto libraries to make it work. And as Keno mentioned, problems with the IPFS gateway, fetching the data from IPFS, and in general working with older browsers. What improved until today? A lot improved, actually mostly everything improved that we said that's bad. Also, we work together closely with a lot of the teams to figure out, like, to improve our skills in working with the blockchain and to improve the tools we have around it. So now all these infrastructure issues we mentioned were basically figured out. We have a good set of tools now with contract editor, various contract editors even nowadays. A lot of SDKs that provide good functionality if you're back on the front end or wherever. Base app is pretty reliable as the apps browser nowadays. We have lots and lots of better documentation, and Sophia highlighting still is a nice thing to have. And also what you can say from back then to now is that we have a lot less breaking changes daily that were coming out. Hey, here's the new version of that's fixing this bug, and breaking another thing, and oh, here's the new 1,000 features that we built and the SDK was not ready. That also got better, a lot better actually. And we have a matured blockchain protocol. Things are figured out. Like in the beginning, we had in the first week some issues with micro-block forks where transactions were stumbled around in the blocks all the time. And this got figured out and also made our life better and better error handling across all the tools that we have. So, app development, it's easier than ever. It's approachable for all devs, I would say. We built a small app with very inexperienced developers in also halfway experienced developers like Emin in the last hackathon in a few hours actually, and it works, and now they can work on for themselves because they know all the starting points, and aeternity is reliable and performant. We wanted to mention in the talk also things that will help app developers coming with the next hard fork and in the more far future. So in the next hard fork, we will receive the Fate virtual machine, where we had a talk earlier from Eric about that will give us unbeaten efficiency and safety across smart contract execution. We will have more support and better interoperability with all the wallets and platforms we have, for example, the wallet extension, base app, and maybe future other wallets and other existing wallets right now with, for example, AX2 expansion that we're working on, or not we, but the team is working on. A lot more standardization in form of AX in general. Eventually in the future, native tokens where app developers can rely on something that's baked inside the protocol instead of using token contracts as you would do on Ethereum. More language features in general, and better documentation and guides as they are always being worked on. So what are some basic rules to build your own app? Just don't over-engineer it from the beginning. Don't think, do I have really to use Oracle here, state channel there, and the naming system here? Just get started, like making a spend transaction, then do your first smart contract, first 3 lines, and see does it work, and then expand function by function. And if you're at the point where you say, I really need an Oracle, or I cannot scale without a state channel here, then start thinking about these issues. So start simple. Find your concrete need for blockchain is one point, because we could, for the Graffiti app, for example, we could have saved all the images on aeternity blockchain. It's not very expensive right now to do that. It will get more expensive in the future, probably, when the need for blockchain rises. But think of, where do I need blockchain and where don't I need blockchain? And always consider supporting infrastructure. That's also always should be public verifiable. For the governance app and for the Graffiti app, we run a server, but everybody can host a server himself. Everybody can see that what our server did and the data our server provides matches what everybody else can calculate on their own machine and with their own input data, and all the data that we fetch from somewhere it's public in either in APFS or in the blockchain. So Keno will talk a little bit about how to get started, build your own app.
Yeah, so we wanted to give people just like a quick primer on how to build your own app. So the first step to this would be make sure that all your dependencies are up to date, because everything mostly only works with the newest version. Then a very easy way to generate your first account is use the ACLI. You can install it with the command you see here on the screen. Then use the public key and enter it into the faucet, and you will get some testnet tokens to play around with. You can learn all about Sophia in the protocol repository, and write your first contract in one of the contract editors. Fire editor, for example, has a nice linter as well. And then you can test your smart contract with a project and deploy it on the testnet. And obviously use the SDKs to make contract calls from your app. So we also wanted to touch on some best practices that we learned during developing our app. So what was nice for us is make it open source from the beginning. This really helped us to get outside help in, so we could say people, hey, just clone the repo, run this, and then you should get the error, and then people could actually follow up with us and say, yeah, you should try this or fix this. What we found is that for all of our apps, we needed some sort of backend. For example, for the governance app right now, we do the vote counting on there. You can obviously do it on a node, but it would take forever, and this is a really bad user experience. But we also made a mode where you can use the app without the backend. So if the backend happens to be down or you don't want to connect to the backend, then you can still vote and see all the polls. We also try to provide a script for users to also verify all the results that we are showing. We do this also in the same repository, and we do this because you can verify it first on your local machine, and also a single script that you provide is a lot easier for people to actually check if it's correct compared to checking your whole app. Something we also do is we wrap our wallet connections in an extra component. This makes it easier for us to actually add more wallets in the future. We had different ways of connecting to wallets in the past. Right now, we mainly use the base app, but with wallet and other browser extensions and more utilities coming up, this is a good way. And also, obviously, check the existing documentation, and if you find errors or you think it's outdated, you can improve it and help the community. Here is a long list of resources. I won't go much into detail, but if you're interested, these are the points to start. We actually linked all of them. You can find these resources and the links also on the hackathon, the GitHub hackathon page from Prague here. And just check them out. We actually built, like the last point is we built a boilerplate based on the apps that we developed. So this is an easy way for people who want to build apps inside the base app. You can just clone this repository and start hacking. Yeah, that's it. Thank you.
Pick your hand up to ask the question. Come on. Don't be shy. Oh, come on. Do you want to walk, maybe, do you have it like a demo or something like that? How it works with the blockchain and everything, I know? Do you have a demo of that?
We don't have anything prepared, I think.
Yeah, well.
Everybody can check it out.
Yeah, it's right actually, right next to the other stage, yeah. Okay, so give another round of applause to the guys. Okay, thank you.